All right, Patriots, welcome back to page 2. Let's go ahead and keep plowing on this thing. For 23 through 27, refer to the figure at right. Identify the special name for each pair of angles. I actually think that should really say through 25 because we're not actually naming angles on 26 or 27. Now, as far as what our possibilities are here, the only things we're going to really get when we have a transversal, we could have vertical angles. We have a linear pair. Now those are our unit 1 things. Then we move on to unit 3 and we learned about the transversals themselves, and that's going to be alternate interior angles, alternate exterior angles, same side interior, as well as corresponding angles. Now, our alternate interiors are the ones that end up on opposite sides on the inside. Alternate exteriors, same idea, like 2 and 7, but on the outside of the lines. Same side interior would be ones like 3 and 5 here. And then corresponding would be similar to like 2 and 6, where it's in the same relative position. So we got top right for 2 and top right for 6. So those are all of our options here. Now let's look at them in particular. Number 23, number 4, or angle 4 and angle 8. Well, bottom right, that's going to be a corresponding set of angles. Now 2 and 7, I'm going to box these. 2 and 7, actually that's the exact one I used for an example a second ago. They are on opposite sides of the transversal line, and they are both exterior, so those are alternate exterior angles. Now 3 and 5, let's underline those. Those are both inside and they're on the same side of the transversal, so they're both on the left, which means that those are going to be same side interior angles. All right, now for number 26. If the measure of angle 2 equals 75, find the measure of angle 6. Well, 75 degrees. Angles 2 and 6 are corresponding angles, and corresponding angles are congruent, so the measure of angle 6 is exactly the same as the measure of angle 2, 75 degrees. Now, on 27, if the measure of angle 3 is this, and angle 5 is this, well, we've already said earlier that 3 and 5 are same side interior, and same side interior angles are supplementary. So our base equation is something plus something equals 180 for supplementary angles. Well, that's 8x plus 10 is that first angle. 3x plus 10 is the other angle. Now let's go ahead and combine the like terms. 8x and 3x is 11x. 10 plus 10 is 20 equals 180. Now let's subtract 20. 11x equals 160. And then divide both sides by 11. And I don't have that one memorized. 160 divided by 11 is 14.55. Now on to number 28. Make a conjecture about the next term in this sequence. Now, our conjecture is just basically we're using our pattern that we're seeing to make a prediction about the next term. So we're going to look at what's changing and get from one term to the next. Could be adding, could be multiplying, could be squaring, could be something else. We're just looking for a pattern. Well, what I'm seeing first, I want to try and do adding if it works. I'm going to have to add 8 to get from 16 to 24. Looks like it works again. Yeah, I'm adding 8 each time. So if I add 8 again, that's going to put me at 48. Number 29. What are the lengths of the sides of this equilateral triangle? Equilateral is important because equilateral means all 3 sides are equal. Now, since all 3 sides are equal, I just take 2 of these sides and set them equal to each other to find for x. And then I want the side lengths. From there, I'm going to plug the x back in and get the value. So just pick 2. I'm going to do 3x plus 6 equals 5x plus 2. Well, subtract 3x on both sides gives me 2x. Subtract 2 on both sides gives me 4. Divide both sides by 2 gives me x equals 2. Now, a lot of students want to just go right there and say, hey, that's the answer. And also be aware that on a multiple choice test, I would definitely make this one of the incorrect multiple choice answers. Okay, got to make sure you're paying attention. What is the length of the sides? So I'm going to go over to one of those, 5 times 2, and plug in x. So 5 times x plus 2. 5 times 2 is 10, plus 2 is 12. Make sure you're not taking that bait on a multiple choice multi-step problem. All right, number 30. We're going to be using this diagram on the right. What is the measure of angle 1? Well, if this angle is 170 degrees, since these two are a linear pair, they must add to 180, and that's what I can do in my head. This one is just going to be 10 degrees. Well, now all 3 of these have to add to 180, so 90 plus 10 plus x, I'm going to put an x in there for angle 1, equals 180. That gives me 100 plus x equals 180. Subtract on both sides gives me x equals 80 degrees. Now, what's the measure of angle 2 for number 31? Well, if that's 170, this has to be 10 degrees. Since this is an isosceles triangle, the 2 legs are equal and the 2 base angles are equal. So this is also 10 degrees. And then angle 2 makes a linear pair with this 10-degree angle, meaning it must also be 170 degrees, because these two add to 180. All right, number 32. Determine the slope of a line that contains points F and G. Remember our slope formula, m equals y2 minus y1 over x2 minus x1. Here we've got x2. How about I just start over on that and actually do it right? Okay, x1, y1, x2, y2. So let's plug it in. y2 is 2, minus y1 is negative 4. My negatives make this become positive 4, over x2 is 1, minus x1 is 3. 2 plus 4 is 6. 1 minus 3 is negative 2. And simplify 6 divided by negative 2 is negative 3. All right, number 33. Which is an equation of the line with a slope of 8 and a y-intercept of negative 3? So where slope equal of 8 means slope is our m value is 8. The y-intercept is b equals negative 3. And so for our our slope-intercept form, y equals mx plus b, all we're doing is plugging these two values in. That gives me y equals m is 8, x, and then b is minus 3. Y equals 8x minus 3. All right, let's cut the video.